Hi, everyone. It's been a great day so far. Amazing demonstrations given. Thrilled, simply. So a bit about rentalcars.com. I joined the company about 7-8 years ago. It's basically a car rental brokerage business. We are sitting in the middle of companies like Abbas, Hertz, Europcar, and we sell their cars for them because they're too busy washing them. And yeah, so I'm working as a principal database engineer for them, rental cars at the moment. I have been in architecture roles previously, started as sysadmin essentially. So this is something I quite like, and I thought it would be nice if I share this with you. So different databases are designed to solve different problems. Using a single database engine for all requirements usually leads to non-performance solutions. Storing transactional data, caching session information, and traversing graphs of customers and the products and their friends bought are essentially different problems. It's from a book about polyglot persistence by Pramod, a very good book. So an introduction to the company. We're part of the Priceline Group. The other companies in the group are Booking.com, Agoda, Priceline.com themselves, and rental cars. Kayak is also a member of the group. The rental cars has been around for about 12 years. We have a multi-layered web application. Obviously, it's an e-commerce business. We have a large MySQL replicated estate, which is read mostly. Not many writes happening, but yeah, lots of reads happening. Some of the internal systems face customers, other face suppliers, from which we get the availability and pricing data, mostly in real time. We're a team of 1,500, and we are spread across 6 locations, headquartered in Manchester. That's where I'm from. We are a team of 6 database engineers. So this is from the perspective of an operations/database perspective. We do have a DevOps culture, and we do try to do agile development, which mostly works. So a typical, very simplified view of how the application stack looks like. So we got front-facing web systems, then we have a search kind of thing, like a box in the middle, which goes away to third parties, fetches pricing and availability, passes them on to the customers, and also deals with a very big MySQL estate, reads from there for availability and location data. We were having some scaling issues, obviously. So a developer said, it's a good idea to add a cache. So they added a cache to the application itself. And what we ended up with was something like, that was a story. Well, basically, I'm rewinding in time. That was 2010, 2012. We introduced caching in the application servers themselves. So that helped in a big way, that a lot of load from databases was taken away. But still, when the app server was started up for the first time, the cache would be loaded with things for the first time from the database. And that would take a long time, put excessive load on the database layer. We wanted to get better on that. That wasn't helping. So we had many individual pockets of cache that wasn't helping. So lots of common elements were cached everywhere. Hundreds of copies of each data element were being fetched too many times from the database. So the hit rates for these individual caches were not really very good. And to further compound the problem, we actually had the systems across 2 data centers. And that wasn't helping either. So that was a lot of load on things. How do you improve? Well, we felt the need for having a shared cache between the application servers, so we move away from that individual private cache thing. That should also help us decrease the priming load. Whenever we do a release, we need to restart the app servers, for example. That could bring down databases sometimes. So we started looking at what was available. Memcache I had used before, didn't really like it. Cold cache problem always hurts when you restart your cache. So we made a choice, did some comparisons. Couchbase at that time offered us with a very precise and clear roadmap for the future. It was a simple solution to the Memcache cold cache problem. And the reason I basically fell in love with it, an easy to manage UI, and it allowed effortless scaling for that. So that was great. Meanwhile, while we were evaluating this, and we had something like a production thing coming up for the cache use case, it was decided. Another team who were tasked for creating a new email system, that was from scratch. They were not modifying an existing system. They started looking at Couchbase. They found it very interesting. And they actually completed their proof of concept to almost getting production ready in about 6 weeks. That was while the caching solution was being prepared or being tested. So they actually went live before the cache solution went live. That's an amazing story. I would call it revolutionary because those developers are still very happy, I'm sure. So these two use cases basically describe one use case where there was an existing system that was seeing the normal issues that you would usually see. And in the other case, you had something in place that would just, there was a greenhouse, or it was being developed from scratch. You've got an open field, you do anything, whatever you like. And using Couchbase there was really revolutionary. So coming back to the, how did we do it? How did the cluster look like? At that time, we didn't really have a 10 gigabit Ethernet core. So how did the network side of it look like? Couchbase ideally needed a 10 gig connection. The solution we went for was to go with some Blade servers with 10 gigabit connectivity within the Blade chassis. Not massive servers, but pretty decent specs for that time, 2013. That's being renewed. Lots more RAM, SSDs. That's a recommendation as well, because I know not all of us are using Couchbase at the moment. I've been approached by many people who want to use it, but they have got questions. So my talk is mainly aimed at them. So yeah, give it a good network connection and try to localize the traffic, and it just performs amazing. So this is how our stack currently looks like. We have 3 different kinds of data going into Couchbase there. We've got the website sessions. They get replicated between 2 data centers. That allows us to, without impacting the user experience, that allows us to move users from one data center to the other if we need to perform any maintenance. And that's something really useful for us. This also means that we need to have enough capacity on either side to be able to run active-active. So that's kind of an operational requirement there. Any questions so far? Please, before I move on. No? All right, too easy. Good. Right. So the other data that goes in there is basically stuff from MySQL that used to go into this local cache previously, directly. So what would happen now is that one of the app servers will pull that in and store that into Couchbase. When the other app servers come up, they actually go there and see if that cache is actually there. If that's a hit, which is mostly a hit whenever you restart 50 of them together, you get primed really quick. So our release cycles have improved a lot. Initially, if we were doing a release, that would take hours. Now we can release in minutes. So massive improvement there. So what benefits have we had from introducing this new caching layer? We have reduced a lot of traffic to our suppliers because we are also caching the results that they return to us. So if someone says, okay, can I have a car in Paris from this date to this date of this type? If someone else repeats the same search before that expires, they will have a hit, and we don't have to go to Hertz and Avis and all that. So that is a lot of savings in bandwidth, and it puts a lot lesser load on the suppliers as well. So they are happier comparatively. Similarly, we have offered our customers a much improved experience as well. So anywhere between 30 to 50% search speed improvement has been seen after introducing this cache. Obviously, better user experience, happy customers, and the business does better. What else have we experienced so far? I mentioned the reduced database layer load, the reduced load on the DB layer. Doesn't mean we need lesser number of database servers. Maybe we can do that. Actually, we reduce the footprint of the DB layer. Any guesses? Sorry? Half. Awesome. Right. So yeah, almost 50%. Almost 50%. So we've actually done away with half of the database servers. We don't really need that big a layer anymore. We did learn a few lessons on the way. I think you can always learn from other people's mistakes, so useful. So you need to make sure that your developers understand tunable durability, because that can bite you. If the developer accidentally says, I'm getting this exception, maybe I should force it to persist on every write, you kind of lose a lot of performance. Yeah, so watch out for that. Also, a smaller number of bigger or larger documents works better than a large number of small ones or tiny ones. You have to gauge, and obviously each use case is different, and you'll have to check and test. But in our use case, we found it more useful to have slightly larger documents as compared to really small documents, simply because there were lesser of them to manage. And yeah. Any questions so far? Well, actually, so.
How big documents, how nested were your documents or fields?
Quite. Like for the email use case, you can imagine that for a certain customer who was sent an email, when was he sent what email, and what the interaction was that caused that email to be sent, for example. So we sent a lot of emails. So the fact that you can have up to 20 megabytes it actually works for us. Yeah, yeah. So any more? Actually, I'm done. So yeah.
About the updates to MySQL database, you still have your big MySQL database, but you use the cache for the search.
The cache is helping the reads.
Okay.
The read scale out we had done.
Every day the search, if you already have the request in cache, you use it, you don't.
For the writes, sorry, could you repeat the question again?
When somebody goes on your
Website.
portal,
Yeah.
he's looking for something, a car in Paris, for instance.
Okay.
If you still have if you already have this search in the cache,
Yeah.
you use it.
Yes.
So you don't need to go to the MySQL database.
No, we don't.
Okay. But you still have to update your big database
Yes.
with all the new prices and
Yes.
the new cars and everything. And you do it every day, maybe?
Oh, it's probably happening right now as well. Yeah.
And how do you still use your MySQL database?
Yes, we do. All the location and availability data still lives in MySQL.
It's like before.
Yeah, it's like before, but we need lesser of that. And it performs better as well because it's not that heavily loaded as before.
Okay. Well, but if you do it during the night, nobody goes on your site.
As a matter of fact,
But it depends. You are worldwide, of course.
we are worldwide, so we don't have that liberty to take things down or
Okay.
take things easy during the night.
Okay, you have to do it. Okay, I understand.
Yeah.
It's not only located in Great Britain. It's okay.
Yeah,
Okay, thank you.
no problem. Any more? Sir?
Hold on a second, hold on. Coming this way.
How do you manage the cache invalidation when there is a change in the MySQL database? Do you using only TTL or something else?
When we get the results back, for example, the search use case, each search result comes back with an expiry time. And that's what we use to set a TTL. So it expires when it's not needed or it's not valid anymore. Another question?
So we are agree that you can have some difference, because if there is an update and if the TTL is not updated, okay, the price displayed to the customer can be wrong.
No, the TTL does not live in MySQL side.
No, it's in the Couchbase site.
It lives in Couchbase side, but it comes from the supplier.
Oh.
So if a search request went to Hertz, for example, and Hertz said, this is valid for 55 seconds.
Yes, in
It
every
will
case,
expire.
you keep the same price for the customer.
Yes.
During his session.
Yes.
Okay, in this case.
During that session, if that has not expired yet. As soon as that expires, it disappears. Any more?
Any more questions, folks?
Did you use persistence from Couchbase or only cache?
We have got two use cases, as explained. So the team that created the email system in like 6 weeks, they use persistence, yes. That's a document use case. And the documents are quite rich, as I explained to the gentleman.
Is it possible that you give us some samples about the read rate on your Couchbase system? Or it's a secret?
Read
How
rate.
many query per second, for example?
Okay.
Just an view.
It depends. Like, for example, the email system, when it's not sending emails, is not very busy. But when it's actually sending emails, it's very, very busy. I can't give you a number. I mean, well, do you want to guess? It's like of the order of 100,000 operations, something like that. So it's not a few thousand, it's not a few tens of thousands, it's quite a lot. And that is not a massive cluster, that's like 6 nodes, but they're good spec, so that's what matters.
Did you plan to extend the system to integrate more functionality in Couchbase to translate from MySQL to Couchbase system?
That search bit in the middle, that was going away to third parties and coming back, that has been re-implemented. That was part of a legacy system that's been taken out. It's implemented as a separate microservice. It's using its own cache as well. Then there's another cache that's being made, or I think they've done with the work, that also makes use of some nickel semantics and plus some so we are using more functionality with time. Yeah. So your answer to your question is yes. Simply. Hi, Matt. There's a question from Matt.
For the caching use case,
Yes.
Are you planning to look at ephemeral buckets when they come in 5.0?
Most definitely. Excited about that.
Any other questions,
Any more?
folks? Okay, with that in mind, thank
Right.
you very much.
Thank
Abbas,
you very
your
much
talk. I really
for-
appreciate it.
Thanks.